So this talk is about SMB debugging tools, or how I like to call it, the art of hair pulling. So who am I? My name is Aurélien Aptel. I work at SUSE in the Samba team. So I mostly focus on the SMB kernel client these days, but I also touch on other projects, so SIF utils, Wireshark, Pike, SMB related things usually. So what is this about? At my work at SUSE, I often have to work on bugs. I would say most of the time, actually. So I developed approaches to solving and finding out what the bug is, usually. And I end up working on new features on some of the tools I listed earlier. So this talk is mostly useful for developers, but also administrators if you want to diagnose better the network issues you have. So debugging is hard. There is no one way to solve every bug, obviously. So some approaches work better than others. So when you have a bug, an SMB bug, it could be either in the client, in the server, it could be in both. Sometimes the specification is wrong. Sometimes the implementation is wrong. Sometimes some of the behavior is not actually specified, so you have to clear that up. So yeah, it's not easy. There's many ways things can fail, and so you want to isolate as much as you can before you actually dig in the code. So the most obvious one, which I'll briefly go over because I'm guessing most people are familiar with this one, is bisection. So with Git or any version control, you can find a good commit and a bad commit, and basically you can iterate by picking one in the middle and finding out if it's good or not. And by dividing by 2 at each step this way, you save up a lot of time. You can find the commit that introduced the issue. So this can all be automated with Git. There's a Git bisect. You can even put a script to do the test for you, and it will automatically do each step. So it's a very time-saving thing. So obviously there's the code reading. You want to avoid this as much as we can usually, because depending on the code size, it takes forever and it's very painful to go through. So, but eventually, you have to read the specs to get an idea of how the thing is supposed to work. You find the corresponding code path in your source. You read the code, you look for bugs, typos, wrong logic, and you do this over and over and over, and eventually you find something. But yeah, it's a long process. It's easy to miss things, and it's my last resort kind of thing. So another way to go about it is trying different implementations. So yeah, sometimes you don't have a good commit you can find to bisect. So where it's impractical to find. So you try different combinations of servers and clients. So you have different clients with Windows. Samba has a SMB client and SMBD. The Linux kernel has SIFS-KO. But there are other ways you can other clients you can use. Samba comes with a torture test framework, so you can write little program that do exactly one thing, which is sometimes easier to deal with than a full-blown client. One I like a lot is Pike. It's a full Python, pure Python project where you can, it's a library framework thing in Python. It does SMB 2 and 3, and you can edit all the packet fields pretty easily. It's very useful. This is what we use to test and prototype a bit of the POSIX extension with Steve and Jeremy. And I know Microsoft has a big testing framework, which I still haven't used. It looks very big and hard to use, so I don't know. So obviously you have the classic debuggers, so GDB and things like this. So these are good tools, but it's very often impractical for Samba and SMB things. Because so every time you do a breakpoint, usually this introduces a timeout, and you end up having to debug things which were not there without the debugger. So it's not very practical. So the way Samba works is it forks the server process for every user session. And so that means in JDB it's kind of a pain to follow the child instead of the parent process. Or sometimes you want to debug both, and JDB is I'm not even sure you can do that. Like break on both process, you have to pick one basically. So these are the commands you can use in JDB to make it follow the children, which is most of the time what you want. For the kernel, so I use QEMU for my VMs, and it comes with JDB server you can interact with. So you just have to add this -s flag when you start QEMU, and then when you start JDB, you can just connect to it. It creates a local, I believe it's a TCP socket, and it will break in the middle of, I don't know which point, but yeah, you break into the middle of the kernel and you can step in there. So it's useful, but again, you have the timeouts, so yeah, sometimes not practical. For the kernel, it comes with a bunch of Python helpers you can use, so you can like little functions to, for example, list all the superblocks, or print out a whole hierarchy of directories entries and things like this. So it's kind of useful. You can still use this if you have a core dump of the kernel. So if a kernel crashes, you can generate this core dump thing, which is basically a dump of all the memory at the time of the crash. And in JDB, you can load the kernel binary and this core dump, and you can see what the state of the system was at the time of the crash. So you can still use those helpers sometimes. It's useful. But the way the kernel is compiled, so I believe you cannot compile the Linux kernel without optimizations. There's always the -o flag which is needed. And this has the side effect of reordering some of the instructions, which when you debug is kind of hard to think about. Sometimes your instruction pointer jumps all over the place in your function, and it's a bit annoying. Some variables are, when you print them, you get optimized out. So you have to look at the registers and look at the disassembly to figure out which is which, and yeah, it's painful. Some of the code, it gets inlined, so it's like a function call turns into it's inlined in the function, and so yeah, following things is tricky this way as well. So I know some of the people upstream are working in making this easier. So yeah, since GCC 4.8, there's this -o which you can use, which makes it better for debugging. I haven't really tested that out yet, so yeah, if anyone wants to talk about this later, I'm interested. So the next big thing is logs. So Samba can generate pretty verbose logs. You just have to put log level equal 10 in your SMB conf. And they're so verbose and big that it's hard to use sometimes. So since I'm an avid Emacs user, I've worked on a little SMB log mode tool, which I'll demo now. So I have this log file here. It's a classic. Can you read fine? Yeah. It's a classic Samba log. So I open it with my Emacs. I can actually do it from here. So it adds a bunch of color highlight, but key bindings to jump from one message to the other this way. You can collapse messages. So let's say you can use tab to expand and contract and expand your messages. So if you press enter in any of the message, let's say this one, it will. So you can see the source file is listed up there, and you can basically jump to the source this way. So it's nice to explore. So yeah, this I just jumped to the print statement basically. So yeah, it's very useful, I think. So another feature I've made, you can, each message comes with a debug level, which is printed here. So this one would be 10, which is the most debug verbose one. So you can filter out the level currently you're viewing with the plus and minus. So we were already at 10, so we cannot go above, but I can do minus to like only see the first level of debug messages, for example. So yeah, it's pretty useful. So for example, when you have a lot of you want to see, for example, this IPv6, and you want to see where it's mentioned, you can add highlights. So I type H and A to add a highlight. Let's say I put the last group of digits of the IP, and I can set up multiple ones. So let's say FFF. So it's pretty useful to explore the log this way. You can filter out by you can filters for file functions. So let's say if I only want to see messages from ndr.c, then yeah. So yeah, it's pretty useful. It requires you to use Emacs, which I know it's not everyone's cup of tea. Did I miss something? Yeah. So wait, I will reset every filter thing. So if you press R, you see all the SMB2 requests that have been that are present in the log, and you can see the response. So of each request. So let's say this one is a query directory. So the last query directory usually returns this error, which means it's the end of the listing. So if you press enter, whoops. Okay, let's say this one. No. Okay. Okay, that's the demo classic issue. Okay. So when you press enter, it jumps to the part of the log which covers this specific request, and it highlights the background. All the messages that belong to the processing of this particular request is highlighted. So you can see the slightly green tinted background here, maybe? No? No? Okay, let's see. Yeah, it's better? Yeah. So yeah, all the message with the green background basically means it belongs to this specific request. So it's useful to debug. So yeah, that's it for SMB log mode. So for the kernel, there's a bunch of statements you can use to make it as verbose as possible. So yeah, you just run this, and when you type dmsg, you see in the kernel logs, you see all the debug info sieves can generate, and it's pretty verbose, so that's useful. So recently, I've also picked up on Ftrace, which is it's like strace. So it records so strace records what a process does, all the system calls it does to the kernel, and it shows you the return value, the parameters, and such. Ftrace is, you can see it as a similar thing, but it goes deeper in the kernel, so you can actually list the call stack within the kernel. So yeah, I've put a link there that covers the like a tutorial on it. But I also have a couple of examples here. So yeah, I see it as a deeper strace. So you can record the call graph of functions inside the kernel. So you can interact with Ftrace through this trace-cmd utility. So this command, for example, will record. So there's a prelude. When you compile kernel functions, there's a little space at the top of the function, which is left out. so that you can enable or disable this ftrace thing. When you enable it, basically there's a bunch of code that gets run before each function that records the state, the call stack and such, so that you can list it afterwards. So this trace command would record all events and print when each function and what function gets called. And then you pass it a command line, and basically it will record whatever this command line triggers within the kernel. So this is very useful. So if I mount a SMB share, when I list when you type report, it lists what it recorded, and you can see it has all the functions. So this is just an extract of it. It's pretty verbose. It shows all the functions that got called, and it's indented in a way that shows you the call stack of it at the time. So it's very useful. You can filter out functions you don't want to see. For example, this str dup, usually it's not buggy, so you don't want to see it, but yeah, it can be useful sometimes. So you can either use ftrace through this trace/cmd program, but you can also interact with it through the /proc directory. So in the previous example, I recorded one specific process, but you can also just do system-wide recording. So we had a customer at SUSE who was complaining that his SIF's SMB mount point would automatically disconnect after 5 minutes or something, and it would happen repeatedly. And he thought the SIF's kernel module was buggy, but the way it happened, and after I asked him to list some of the system details, I realized something was actually making a unmount system call, but he had no idea why. And to find out what did, I did this I asked him to do this system-wide ftrace recording, which basically says every time you enter the syscall entry point of the kernel, and the ID of the system call is 165, which is the number of the unmount or mount syscall. So this would record everything that triggers this system call. So I would tell him to run this, wait for the unmount to happen, and then report and see send what he got back. And it turns out that in the report we could see that there was a process that would issue this unmount call. And from there we investigated more and found out there was some sort of script he installed that did this. So SIFS was not at fault here, so that was good for me. I could pass on the bug to someone else. So as I said earlier, you can use the trace/cmd program, but you can also just interact with the file system. So this is just a shell script that would do basically the same thing I showed earlier. You don't need a separate program, which is useful for a customer which don't want to install another package sometime. So it's pretty straightforward. So everything happens in the /sys/kernel/debug tracing. This is in DebugFS. So if this is not mounted on your system, you can just mount DebugFS somewhere and use that path instead. So there's a bunch of pseudo file there, and so if you want to filter out the sysenter event, you just it's pretty simple. You just echo this in this set event file. Filters go through the subdirectories, so everything is a pseudo file there, and this is how you interact with it with the API. When you want to start the tracing, you just echo 1 in this file, and when you want to stop, you echo 0. And then to print the listing, which is here, you just cat this trace file. So it's very simple. And this echo 0 basically clears out the trace. So very useful. So the next big thing is network capture. So if you have a bug, you just, it's like a wire log, you just record whatever happens on the wire, and you can open it in Wireshark and dissect all the packets. Very useful. So this is usually the filter I use when I use Wireshark. So SMB1, SMB2, DNS, and Kerberos. Sometimes it's useful. So I mentioned I worked on Wireshark. So lately, a very useful features I've worked on is Wireshark decryption. So it requires Wireshark 3, which came out in February. So it's very recent. It supports 3.0 and 3.11 decryption, because the keys are generated different ways in those two versions. In order to work, you have to give Wireshark the session ID and the session key, which you want to get decrypted. So in order to get those two things, so for Samba, I sent a patch which is not released in Samba yet. It's still in the Git branch, master branch. It adds this debug encryption option. When you put it to yes, it will, for both the server and the client, it will dump in the logs those sessions, IDs, and keys. So you can set this in the SMB conf file or directly in the command line in SMB client. And for the kernel, there's this debug config option which you can enable. It's obviously off by default. You have to recompile your kernel if you want to get it. So you just set this to yes, and it will dump in the kernel logs those keys. So for example, here is how you would use it and how it looks like. So SMB client, you put this dash option, decryption, debug encryption. -E makes SMB client use encryption, then this is the protocol version. So it dumps those two things and other things. You just have to start Wireshark and pass this via the preferences, the session ID and session key. So I've used colors to highlight what is which is which. So I can show you briefly how it looks like. So I'm extracting the ID and keys via a little script, but yeah, it's doing the same thing. So this is a decrypted trace. So you can see here the transform header and encrypted data, and yeah, from there on it's similar to what you would get without encryption. So yeah, pretty useful. So for the moment, only one mode of encryption is supported, CCM or GCM, I forgot which it is, but that's something to improve, add all the other modes. So for the kernel, it looks similar. Once you've enabled this config option, you just type DMSG and look for the saves messages, and it will look like this. So yeah, see, it's pretty similar. There's also a GUI option you can go through within Wireshark to set those things up. You have to go to the preference, SMB2 options. Then there's this secret key for decryption table thing, and yeah, it's similar. While I'm talking about Wireshark, some other new changes that got in recently, which I worked on, is better parsing of the compounded responses. If you had dissection issues, bugs with Wireshark when dealing with compounded packets, probably this will get it fixed. Similarly, error contexts work better now. I've also added support for the POSIX extensions. We are going to reuse some of the NFS reparse tags. So I've added support for this in Wireshark to help out debug saves .ko. So yeah. So network captures are nice, but oftentimes you want to have you have a working case, like you have a client that works and a client that doesn't, and so you want to compare those two traces. And within Wireshark, it's not so easy to do, I think. So yeah, you have to look hard at both traces and see what the good client is doing or what the good server is doing and what the bad one isn't. And you have to compare each packet, each field, etc. Yeah. So for doing that, I used to open two Wireshark windows, expand all the little handles, and there can be a lot of them. So you have to click, 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 plus, plus, all the little twisties. Eventually, you switch to a different packet and everything collapses again, and yeah, it's very impractical. You click a lot. You keep expanding fields, thinking the fields will be different, but actually most of the time it's the same. So it gets very tiring. You miss things out. There's so many things you could miss, white space differences, uppercase, lowercase things, slash directions, flags. There's a lot of things you can miss. And some things are different, but that's normal. Timestamps will be different. Quids will be different. Hashes will be different. So yeah. So looking at all of this, I thought it would be great if we could automate this comparison. So Wireshark doesn't really have an API, but there's a text version of it called Tshark. Yeah, it dumps text output, but you can also select different output formats like JSON, XML, whatever. And there's also daemon, SharkD, which apparently can dump things, cache it out, so you don't have to call the same binary over and over, which I haven't tried, but it's something to look into. I ended up using Tshark, so Tshark is pretty similar to Wireshark. You just call Tshark, you pass the trace, eventually a filter, and this is basically the main window you see in Wireshark in text form. If you add -v flag, you will dump out the every single packet. This is the equivalent of expanding all the fields, basically. So seeing this, I thought, okay, I can probably just call Tshark twice and do a diff like this. So yeah, I've first prototyped something in Emacs, which you can still get. But I thought, yeah, people will find this more useful outside of Emacs. So I ended up writing a little Python script that would do what I said. So this tool has a single trace mode, which is similar to Wireshark. You open one capture, you see all your packets and the details below. There's a diff mode, which opens two captures, and in the middle you see a diff of the packets. So I proposed this as a Google Summer of Code project this year, and some student got interested. So we will probably see more improvements on this particular tool over the summer. So I'll do a quick demo of this. So since Wireshark now supports decryption, and I will make this extra useful by diffing two encrypted traces, which if you were to compare byte by byte, it wouldn't be useful because of the encryption, because they're encrypted with different keys, obviously. So the tool can extract the keys from kernel log messages. So I've just passed two traces and their respective kernel log to extract the keys. So this is what it looks like. So I can go up and down, and it will move the cursor on both windows. And I have key bindings to move inside the diff. So you can see here the difference is mostly time related or hash, so it's not really something you can ignore this basically. So this is diffing two encrypted traces. Yeah. I've also highlighted in the upper view all the errors in red to make it easier to spot. So the difference between those two captures is that one of them has signing required and the other one has it enabled. And so in order to find this out, we'll see that it's much quicker to do it through here than expanding the fields in Wireshark. So yeah, this is signatures, IDs are different. Yeah, that's okay. Nope.
The traces weren't quite the same.
So, right. So, if the traces are not exactly the same, for example, you have extra packets on one side and not the other, you can move the cursor independently. So, let's say, yeah. And you can align, yeah. So, in this, yeah, here you can see, in this packet, you can see the actual differences between the two traces. And you can see one has it, so on the left, it was signing enabled, and on the right, it's signing required. So, yeah. It would have taken a lot more time to find this out if you were using Wireshark graphically. So, you had a question?
Yes, one question. Is it possible to filter on fields in the diff that you don't care about. So you can filter out fields like timestamps and so on. You know, this expected to be different. So I don't want to have that appearing in the diff. Is that possible? Maybe as an enhancement for the Google Summer Pro?
Yeah, it's part of the list of improvements to make. So currently I'm just using the text output of Tshark, but in the future I would like to use the XML output and really do a deep diff of it, because it's a tree-like structure and you can do smarter ways to diff, I think. And I was thinking of having a way to input rules for ignoring things and or noticing things. So this is not done yet, but it's something I'm thinking about and could be done in the Google Summer of Code by the student. So I wouldn't have to do it myself. So yeah, that's pretty much it. I have one more slide, I think. So future work. So in Wireshark, there's the new negotiate context, which Tom Talpi has mentioned earlier in this conference. The support for compression, that would be nice to have. Implement decryption for all the other modes. So GCM or CCM, I forgot which. And the third one, which also exists, I think. And if you have other ideas, that something that annoys you in Wireshark that could be fixed, and we can talk about it. The SMB compare tool, as I said earlier, deeper analysis, the ignore rules, as you mentioned. And so my student working on the Tshark is interested in making a better UI, maybe something graphic. I've heard people from Microsoft complain that the text console is not the best, so something more. Something prettier to look at would be maybe interesting. And something else I would like to delve into is the so QEMU, which I use to run my VMs. There has been some work into having it be able to record and replay a run. So all interaction with the outside of the VM could be recorded and played. And someone worked on this for a Google Summer of Code as well. But I don't think it got merged, or I don't know what the state of it is, but it would be extremely useful for me. I could finally use the GDB debugger, and without the timeouts problem, I could just repeat, record, go backwards, go forward. It would be really useful. So yeah, that's it. If you have any questions.
Do you have any plans for a UI for the log viewer, for the Emacs log viewer, for people who don't want to use Emacs?
Not at the moment. Just, sorry, no. I'm not against it, but it's working for me now, so yeah.
Did you already have a chance to look at the BCC tools, the eBPF stuff?
I only recently figured out how to use Ftrace, and I know eBPF is on the list of the next thing to use.
You should. It's a world of opportunities. It's basically like you could write scripts in Python to do anything for you, that like things that Samba tracing already does, but you can just invent anything you like. And
so you can print out anything with eBPF? Because we have traced...
No, much more. It's not that you can print out anything. You can use the map to accumulate statistics about latencies between points in time that you choose, stuff like that.
Okay, sounds useful.
Yeah.
So the work that's already done, what version of Wireshark has it?
So if you want to use decryption, you mean, or?
Well, the decryption is already there, but like you're comparing tool and
it's a separate...
some of the new SMB operations, is that upstream in Wireshark right now?
So the things listed here, you mean the new things here? Or?
Yeah.
So this is not done yet. This is future work, something that could be done in the future.
Oh, all right.
Decryption is already in 3.0.
Yeah, that's been there for a little while. Right.
And the compare tool is not part of Wireshark. It's a separate project.
It's a separate protocol, program on top of it. Huh, okay.
I should have put a link to it, but you just type SMB CMP and it's on GitHub.
Yeah, I've seen that. Okay. So apart from your Google Summer of Code, do you have any other help or volunteers on this?
So David Mulder from SUSE has helped me with some things, but no.
So it's
I'm mostly
okay.
my own thing, yeah.
Yeah. All right. Interesting. All right. Thanks. It's good.
All right, thanks.
Thank you.